So now let's move to the next question. Question number 42. Question is point having two circular arcs joined by the two radial showing figure. It carries a current of 10 ampere magnetic field at point O. So let's see question number 42. Solution for this. See, we know that this magnetic field is given by mu naught I theta upon 4 pi. Okay, so we have given two circular arcs here. One is for 3 centimeter and other is 2 centimeter. Okay, we have to calculate this magnetic field in this way. So for this, we have the formula. We use this formula, and this formula we get theta here is 45. So mu naught I upon 4 pi. Theta is 45, that is 5 by 4. That pi to pi cancel. Mu naught I upon 16R. Okay, and same for other. Mu naught I2 upon mu naught I upon 16R2. From that, because this direction of the current in upper loop and lower loop are opposite, so they will minus. So magnetic field will become mu naught I upon 4 pi 1 upon R minus 1 upon R2. Mu naught I, that will be 60 1 upon R 1 minus 1 upon R2. So by putting these values, we get all by putting the value of the I, that is 10 mu naught 4 pi into 10 raised to power minus 7. 16 R1, R2, we have given these values. So by putting these values, we get value of magnetic field, that is 10 raised to power minus 5. Okay. Moving to the next question, question number 43. That is, consider the flux time graph for a circular coil given below the select option. Select the correct option. See, this is the phi versus t, flux versus time. So we know that the epsilon EMF is minus d phi over dt. So here it is constant value. So for the constant, the derivation will be equal to the 0. So EMF will be equal to the 0. So see the option. Induced EMF between t equal to 0 to t is non-zero. Now it is 0. Ta equal to t magnitude of EMF induced will be same. That we have not checked. Move to the next option. EMF will induce between t will allow to flow the current in the same direction. Induced EMF will be 0 between 0 to t. Yes, this option is correct. Option number 4. Next question. Question number 44. The plane concave lens fits into the plane concave lens fits into the plane of convex lens. Their surface is parallel to each other. U1 and U2 are 30 centimeters. Focal length into combination. See, we have the next formula. 1 upon f is equals to mu minus 1 minus 1 r1 minus 1 upon r2. So here the plane concave lens is fitted to the plane of convex lens. So for the first one, 1 upon f1 is mu1 minus 1 upon r1 minus r2. See, for this plane C or plane of concave lens, suppose we have taken this plane of concave lens. This is plane of concave lens. So first one r1 will be infinity, 1 upon infinity minus 1 upon this r2 will be positive. So we get the mu1 minus 1 upon infinity, there is 0 minus 1 upon r, that will be 1 minus mu1 upon r. Similarly for the second, that is plane of convex lens, the r1 will be infinity, That is, suppose let's see here we have this. So with this R1 will be the this R1 will be the positive and R2 will be the infinity. So we get the mu2 minus mu. So 1 upon F is equals to 1 upon F1 plus 1 upon F2. When is not working. 1 upon F is equals to 1 upon F1 plus 1 upon F2. So from this we get mu2 minus mu1 upon R. We have given the value of mu2 and mu1 and the R, then we have the value of the focal combination of the focal length. Okay, next in the reverse bias PN junction diode. We know that in the reverse bias, see this is the P and in the reverse bias, positive side connected to the negative and the negative side is N side is connected to the P side connected to the negative terminal and N side is connected to the positive terminal. So P side connected, the positive terminal is connected to the P side and negative terminal multiplication will become the N. See, in the reverse biasing, the negative terminal is connected to the. So there is something wrong here. Option number for the positive terminal is connected to the N side negative terminal, P side definition detail. Yeah. Option number 4 is the correct for this. Let's make correct. Option number 4 is correct here. Okay, there is something wrong. Question number 46. If the frequency of the incident wave on the metal is mu is the speed of the electron is v, if the frequency of radiation is twice the correct option. See, for the electric we know that the h nu is equals to E max plus work function. So kinetic energy of emitted electron becomes the twice. Kinetic energy of emitted electron becomes greater than twice, and the kinetic energy of the emitted electron less than twice. Kinetic energy of less. So kinetic energy of emitted photoelectron become greater than twice. Option number 2 is correct on this situation. Question number 47. The ground state of energy of nitrogen atom is minus 13.6 eV. Energy required to analyze hydrogen atom from the second excited state. Second excited state, we want to find out the value of the analyzation energy. So C E is equals to minus 13.6 divided by N square. For second excited, first this ground state 1 n equal to 2 is first excited, n equal to 3 is second excited state. N equal to 3 minus 30.6 divided by 9, that is equal to minus 1.51. So for ionization, we need the plus 1.51 energy. Okay. The moment of inertia body depends upon mass of body, distribution of mass in the body, axis of rotation of body, all of these. This moment of inertia depend upon radius also, mass also, and the distribution of the mass in the body also. So it's all of these are correct. The de Broglie wavelength of the neutron at 927 degrees Celsius, it will be greater than 27 degrees Celsius. So we know the formula for the de Broglie wavelength. See, we know the formula for the de Broglie wavelength of the neutron. That lambda is equals to h upon root 3 mkt. T is the temperature. So lambda is inversely proportional to the root of T. See here. So lambda 2 upon T1 equal to root T1 upon T2. So T1 here, see, 927 we can convert it into Kelvin by 273 add and 27 273 add. Okay, then we will get 1200 upon 300. Okay, that is for root 4, that will be 2 lambda. Option is 2 lambda is correct. Now last question, 50th number. See, this is experimental based question. The pitch of the screw gauge is the 1 mm and there are the 100 division of the circle. A student measures the diameter of the wire using the screw gauge and he gets the main scale reading at 5 mm and a circular division 25. The screw gauge has the positive zero error. Is 0.033 mm correct value. See, screw gauge has the 100 divisions and its pitch of the screw gauge is the 1.1. Okay. So the least count of the screw gauge will be the pitch upon number of division, which is 1 mm. Okay, this is the least count. So we want to know the reading of the that we have calculated the thickness of the wire. So we want the reading. So the main scale reading is the 5 mm plus circular division is 25. So its formula is this one: main scale reading plus circular reading into least count. This is the initial reading. That is 5 mm. The circular division we have the 25, least count we have the 1 mm upon 100. So 1 by 4. So we will get 5 mm plus 1 by 4 mm, 0.25. So 5.25 mm. This is the main. But here it is given that it has the some error, that is plus that is a positive zero error 0.03 mm. So we will uh, so we will uh, actually remove this error. Okay, so we have this reading 5.25 minus this error 0.03 mm. So actual reading will be 5.22 mm. Sorry, mm. Okay, so option number 4 will be the correct, so correct answer. So this is done. Thank you so much. If you have any of the doubt, so do ask me in the comment section. I will reply ASAP. And hope you will like the video. Do follow the memo neat. Thank you so much.